For the consideration of the second order system, first, second order system in numerator, they have a standard form of the second order S2 plus 2 sigma omega n plus omega n squared. Here you cannot go to the first step that you change to the standard form. We go to the second step, that S go to j omega. Then you will find that j omega is j omega squared plus 2 sigma omega n j omega plus omega n squared. As you know, the j power 2 is equal to minus 1. Here will be omega 2 plus 2 sigma omega n omega j plus omega n is 2. These two sentences is a real system and this one is a imaginary. That means the magnitude will be the real squared, imaginary squared, the total will be root of this, and the magnitude of the decibel will be 20 logarithm of the magnitude, and the phase will be arctangent, the imaginary, divided by the real. Then we will check the different omega and we draw the system. First, omega go to 0. When the omega go to 0, j omega, this will be eliminated, this will eliminate, will be omega n squared, and the magnitude based on the decibel will be 20 the logarithm of the omega n squared. This 20 will be multiplied to 20 become 40 logarithm of the omega n, and the phase will be 0. If omega go to infinity, the j omega will be compared to these two sentences is very big. You consider only the first sentences will be minus omega squared. Then the phase of my system will be magnitude of the decibel will be 20 logarithm of the magnitude and will be 40 logarithm of the omega, and the phase will be minus 180 degrees. If you see the magnitude and the phase of the system, two parameter is depend about the magnitude depend about the two parameters, omega and sigma, omega n and sigma. We must consider the sigma between the 0 and the 1. Then you calculate the different magnitude and different phase. First of all, we put the sigma equal to 2, omega n equal to the 0.5. You find the magnitude based on the decibel and the phase based on the decibel. You put on the table different omega decibel and the phase. You can draw this shape. Then you put the and you can find the phase the same thing, and then you change the sigma between, for example here you can put the between 0 until 1. Here they make the 2 just only to find the system, but the sigma equal to doesn't have any meaning. And here we put the sigma equal to 0.05, 0.2, and find the magnitude of based on the decibel and the phase. And we know the phase omega equal to the 0, phase will be 0, and omega go to infinity, phase will be 180 degrees. This here is 180 degrees, and you can make the table and you can find a different value. If denominator In the second order system, you will do the same thing because first step you can standardize. We don't have that. You can second step, let S go to the j omega, then separate the real and imaginary. You find the magnitude and the phase of the system. And if you see here, this is a magnet based on the decibel, and this is the phase of the system. Phase and the magnitude, both of them depend about the two parameters, about the sigma and the omega m. We will make them the constant because we know the sigma is equal to 0.1, and we put omega in some value between the 0 to infinity. Then they fill the table based on the different sigma and omega. As shown in the figure, all of the magnitude and the phase in the second order system, even in the numerator and denominator, all depend upon the different sigma. Okay.